What's up and welcome to DevPath. I'm Brian and I'll be your host in today's video. What is vibe coding and how can we use it to boost productivity and learn faster? We're going to dive into all that plus some tips and techniques you can use to get better results from AI, as well as some pitfalls to avoid. That way your vibe coding dream doesn't turn into the next vibe coding meme. But first, why should you listen to me? I've been professionally coding for more than 20 years. I wrote my first lines of code some 30 years ago. I'm a 2-time patent holder, 3-time startup founder. I've been CTO for a highly regulated casino gaming company, DevRel Learning Journey Manager for a Layer 1 protocol in the blockchain and crypto space. I created DevPath to pass on the knowledge I've acquired over the years. For me, it's a way to give back and pay forward the lessons I've learned from countless other tutorials, courses, coworkers, and all the great developers who took the time and effort to write amazing documentation. So let's dive in and see how we can vibe code a web version of the classic game, Space Invaders. Learning as we go with the help of GitHub Copilot in the new agent mode. So what is vibe coding? I mean, really, what are we talking about here? Well, it kind of started off as a joke, and hence there's a lot of memes around it. We've all tried to generate things with AI and gotten pretty mixed results. Largely a bunch of code that you kind of might feel like you're getting somewhere, and then it's just a sloppy mess and you throw it all away, and it's just a big dumpster fire. But what's coming out of it is actually an interesting new paradigm and way to approach coding that we've never had before. In 20 years of being a professional developer, I've seen a lot of tooling evolution over the years. And the way I see it at its current stage, I think it can be very useful for rapid prototyping and learning. But with that comes some caveats, and there's a particular approach that you need to take to make it useful. So the idea behind vibe coding is that you're not focused on how to write the code per se. You're using AI to really do the heavy lifting on that part. What you're doing is putting yourself in a position where you can focus more on being creative and thinking about what it is you want to build, and leaning on the AI to take that pressure off of having to go out and read documentation and figure out how to build what you're trying to build. Okay, so now that we've got the theory out of the way, let's see how about putting it into practice here. So we're just going to start from scratch. I've got an empty folder set up here. What is vibe coding? I'm just going to drop that into Visual Studio Code, and we're going to use GitHub Copilot. So make sure you've got Copilot installed, and we're going to also want a browser. So let's get just a blank browser opened up and moved over here. We don't need all that space right now. Okay, so first thing I'm going to do, let's stretch this out here, is actually, let's just create a README and make some notes about what it is we want to build here. So our goal is to build Space Invaders vibe coding style. So what I'm going to do, and this step is still rather similar to setting up any project, really. You start putting together your specifications, like what are you trying to build? Now, obviously it's a little looser here because we want to be creative and we're not going to constrain it, but that doesn't mean we can't do a little planning. So let's have some game features. And maybe we'll do a numbered list. So Space Invaders, the basic functionality. We need a player controlled ship. And it should be able to move. It's just simple left, right. Movement. And oh, we don't need and shooting. Okay. Now, and see, Copilot's already trying to, I don't know. Oh, it's trying to fix my typo. Perfect. All right, so 2. We need enemy ships. Left, right movement, yeah. But it's actually left, right. We're not going to do shooting right away, but they descending over time, or just they descend as they collide with the edges of the thing, but we'll get to that. And then 3, we're going to need some collision detection. And see, it's already guessing. Player ship versus enemy ships. Player bullets versus enemy ships. So that's, yeah, that's pretty accurate actually. And then, maybe we'll have score tracking, sure. A game over condition, yeah, of course. And probably a restart. Because if we have a game over, we need a restart. So yeah. So you see, it's already thinking through. The more context it gets on what I'm trying to describe, and this is where the whole vibe coding, AI is doing a really good job of guessing here. I'm not having to type much. So you can actually use it creatively. It's almost like you have somebody to bounce ideas off of. And if you don't like the idea, you just hit escape. No, I don't want to do that. Okay, so now let's say we've got some game controls. Yep. Yeah, left arrow to move the player ship, right arrow to move it, space to shoot bullets. Perfect. Sounds like pretty standard key. R to restart the game, maybe. Yeah, why not? And Q to quit. Okay. And escape to pause. We'll see if we get to all these features, but at least the more we spec out here, this file is going to give Copilot some context. And what we're doing is, so one of the areas people get into trouble is they start building and get really excited and they get a bunch of stuff working. And then they have no idea what all is going on in the code. And so they move on to another feature and AI gets it wrong and the whole project becomes garbage. And so what we want to do is still address it in a similar fashion to how you would develop it yourself, where you build it one little feature at a time. And as we start prompting Copilot here, you'll really start to see this come into play. So the other thing I want to have is actually, let's spell out the project tech stack. Okay. No, we're not going to do Python. We're going to use HTML. Canvas. And JavaScript. Sure, some CSS. I don't want to use Webpack actually. I want to use Vite. And of course, this is just, yeah, for the server and build tool. And then, we want to use Git. Okay, so good enough. Yeah, we're not going to worry about a GitHub repository right this minute, but that gives us a starting point. Let's save that and call that our this is where our project is starting. So the next thing I'm going to do is, okay, now I have a rough idea of what I'm trying to build. And this could be anything. This is just happens to be our example. I'm going to open up the chat for Copilot, and I'm going to switch to agent mode. First thing I want to do is, actually, I think I'm going to add to this. I don't want to go too deep into writing all the physics for collision and everything. So why don't we use Phaser for a game framework? Okay. Now, if you didn't know about Phaser, you could also just start here and ask Copilot, like, hey, what are some JS game libraries that might work well for building Space Invaders, like the old Atari game? Okay, and you can let it recommend, because maybe you've never heard of Phaser or Pixie or any of these. Pixie would be another good option. It's very lightweight, but it wouldn't have the physics engine. So we'll just use Phaser because I know it's going to have what we need. And see, it's telling me you've already got it listed in your tech stack, and it's an excellent choice for building Space Invaders. Yes, it is. All right, so now I can say, how familiar are you with Phaser? And it seems like a silly question, but by asking it that, even though it's already told me it helps to build the context for our conversation. So the more context we give Copilot or whatever AI you're working with, whatever large language model you're working with, the more context you give it, the better answers you can get out of it. Now, the other tip, the very first tip, is as much as possible, phrase things as a question rather than dictating tasks. You'll get far better results by and far on the large, across the board, no matter what you're trying to do, if you can phrase your task in the form of a question. And then the other tip, as I'll show you as we go here, is even when you're assigning a specific task, like you finish that task with, do you have any questions? Because then you give the language model the opportunity to come back and ask for more details rather than just making assumptions, so that your prompt ends up being far more specific and you'll get a lot better results. So let's continue on here. And okay, we know it's familiar. Let's see, I can help you with setting up a Phaser project, creating games, etc. Now, in the interest of learning, so we've talked about we want to make things questions. I want to save this here. Now what I want to do is get the general project structure set up, and I want to approach this as if I have no idea how to set it up or what I'm doing, because we're going to use this as a learning tool. So what I'm going to do is prompt Copilot and say, I want to tell it to walk me through step by step rather than doing it for me. Because I could just prompt it and say, yeah, great, can you set up a basic Phaser project? But what I want to do instead is understand what it's setting up. And this helps you as you go, as you get deeper into the project, rather than just blindly letting it build code, which is where we end up with the dumpster fires. We want it to explain what it's building and why, so we can think about it and second guess it, check its work, and gain understanding of what it is we're building as we go. Okay, so Let's set up the basic project structure. And please explain the steps necessary as we go. Okay, so create an empty folder as a workspace to continue. Okay, we're already in a folder, so we're going to skip that. I'm just going to cancel. I don't want to do that. I'm going to tell it. Okay, now we're back at okay. So we're already in a folder. So, if you had just opened up Visual Studio with no directory, then that would have been a valid step. Since we're already in one, I don't want to do that. I just want to work in this folder we're already in. Okay, so now getting the basic project set up. Now we can use Vite to scaffold a project, which is a good option. Scaffold a vanilla JavaScript template and install dependencies. Now, it's going to ask us if it can run this command in the terminal. So instead of having to go to Vite and figure out what templates are available, we can get this right here. Now, if you wanted to understand even deeper under what was Vite doing to set up this template, you could prompt it now. Can we set it up manually? In fact, let's just do that. We'll just, can we set it up manually so I can learn more about what Vite is scaffolding? Okay. And so now it's going to walk me through doing the process step by step. Perfect. Okay, so now look at this. We've got the first point where, let's see, did it? Yeah, npm-y. Okay, so now this is a point where it's making a mistake, and that's perfect. I'd like to show that so that we can walk through how you overcome these mistakes when you're trying to use Copilot to learn and it makes mistakes, and what do you do then? Okay, because this is where a lot of people get hung up and stuck. So if we already know what Vite's doing, we can just run this command and move on. Great. But since we're using this as a learning tool, we want to understand what's going on under the hood so that we can move forward further with our project. We're going to follow these instructions here. Okay, so initialize the project. We want to initialize npm. Let's get our terminal open here. Okay, and we're going to run npm init-y. Now what that's going to do is accept all the default values. So I'm going to insert that into the terminal, but what we're going to do, instead of accepting all the default values, I want to step through them to show you where it's making a mistake, and I'll explain why as we go here. So we're going to do npm init. With the -y, that just automatically says yes to all these questions that it's prompting me for now. And I don't know if I can increase the size of this. Hopefully that's big enough for you can see. So it's asking me for a package name. So I'm just going to say, okay, I can just hit enter, entry point, index.js. So here's one point. If you look further down in the instructions here, so it's going to create a package.json and install Vite and install Phaser. And our entry point for your game that it's setting up here at step 5 is actually main.js. Now this isn't a huge deal, but it's an error and we want to catch it. So and if you had done -y, your package.json would have an entry point of index.js. So right now I'm actually going to tell it, no, that's actually going to be main.js. Okay. Test command, git repository, not worried about any of this. But here's the next one. And this is where you would experience your first functional error, like things just wouldn't work right. The default would be common.js. And if we look down here at the main.js JavaScript file, it's using import syntax, which means we actually need to tell it that this should be module. So if this is common.js and you go to run this file, you're going to get an error when you run your script that says, you know, module's not supported. It would need to use the require syntax. Okay. So in fact, let's just let it make that error and then we'll fix it. Okay. So if you had just done -y, you've got your package.json and you can see right here, it gave us common.js. Okay. So now let's continue on and I'll show you what happens when you get that error and how, if you didn't know how to solve that issue, we can take that error and get Copilot to fix it for us. Okay, so let's continue on. Let's see, what's it want to do next? It wants to install Vite. So we can go ahead and do that. That's fine. Let that run through. Might take a second here, but it's doing a pretty good job so far. And then the nice thing about stepping through manually is we're going to see how to set up a Vite config file. So you can have custom options. Now this is very basic. We're not going to see a lot there, but if that's what you were trying to learn about, you could dig deeper into it and ask it what your options are. And this is how you use these large language models to learn in a much easier mental capacity. You know, going out and reading all this documentation, you don't necessarily know what you need to read about, whereas these can point you right in the right direction and, you know, speed up what you got going. Now, you notice it's also setting up an HTML file with the correct import for main.js. And my installer is running long time. So while it's doing that, let's see, does it give us commands? Okay, it's just having us create the files. So let's set up our file structure while that's running. Oh, there we go. It's almost there. So what do we need? We need an index.html file. So, oops. So we can create that. Let's create an index.html. Okay, we need a source directory. Oh, escape. We need a source src directory. And then inside that, we want our new file of main.js. Okay, so got that. And then at the root level again, we want one more file that is our vite.config.js. Okay, so there we go. Now, so it installed Vite, so we can continue on and install Phaser. Let that run, and while that's running, we can go ahead and move over here and set up our index.html. Now, the beautiful thing, if you're not familiar with Copilot, we can just insert at cursor what it has given us here. And we're going to do that. That gets our HTML file set up with our import for our main script. And just save that. Okay. And our main.js file, it's even got that scaffolded for us. So with the initial setup for Phaser. So the Phaser library gives us some of your common game functionality just right out of the box. So it figured out we wanted in our README, we want to use the HTML canvas. Well, Phaser gives that to us. And it's even picked a default size for us and then given us these three functions that come out of Phaser. So preload is something that we can use to load sprite sheets, graphics, assets. Create is where we kind of initialize our game, set up game objects. And then this is really convenient. Now, games have a concept of the game loop. So it's constantly checking, updating, and this is how you facilitate moving characters around or enemies coming in or whatever activity is going on in your game. So we get that all out of the box, and all we have to do is go to our main.js file here and insert at the cursor. Make sure you've got a cursor up in your file here, and we can just use this right here. Insert at cursor. Okay, so now we've got our basic, save that. We've got our basic game configuration set up. Now we need to configure Vite. So we'll go to our Vite config, and we can see it's just a default configuration, server, and open true. This just opens the browser for us when we fire up the server. But again, it's nice to be able to see when you're learning, what are you getting out of these scaffolding tools step by step? Because a lot of times you'll scaffold these projects and then you've got to go dig around through the source code and try and reason about it, figure out what it is. Well, now we're getting it explained to us as we go. I wonder if I can, is that a little better? Increase the font size, hopefully without making it too terribly big. Maybe move that so we can see a little more. And we can shrink this down a little bit. Okay, so we've got our dependencies installed. And if we go back to our package.json, we still have this issue, and that's good. I want that to fail so that we can see what the process is like to get Copilot to debug its errors for us as we go, because we're learning here. We don't know what's coming up. So now we can go ahead and, would you like to create these files? No, we've done that. We're going to go ahead and start the server. So let's just insert this into the terminal and get our dev server fired up and get our first error. So there's that. And looks like we've got a canvas here. We can open up DevTools. Okay. And we can see we've got a canvas element with a height and a width of 800 by 600. Okay, so now, so far so good. Interestingly, this didn't error. But what I want to do is actually make this module and save. I was actually hoping it would throw an error in the console. I'm surprised it did not. Perhaps we have moved beyond that, and okay, it didn't get a favicon, but it's allowing our script to run. Interesting. So if it was the other way around, you would definitely get an error here. So if this had, oh, because we're running in the browser, import works. But if this was using the require, then, or we were running this on the back end with common.js, we would get the issue. But so anyways, small detail. We'll get to some errors later and point those out as we go. I was hoping for that error so we could force it to debug, but let's continue on. We've got a functional canvas. Let's add some styling. Let's style the game canvas so that it is centered. Okay, and we're going to let it do the heavy lifting for us. It's generating some updates. What's it going to give us? Display flex. And then, so here, as it's writing code for us, now it's putting it in the HTML file, and that's okay, but maybe I don't want to do it that way. Let's actually create a separate style sheet. Okay, now you'll be able to test these changes. It saves when you're in agent mode. It saves, but don't be too quick to jump on and click keep. Because what you can do is you can iterate through how things are written and see, so now here's something, since we made a change, it's added the style sheet here, but it hasn't removed this. And this is common. It tends to miss removing this. So what we can do is actually go ahead and delete that, because all we want is this style sheet, and we can save. So notice I can save the file, but I haven't kept the changes yet. Okay, and then here, and so if we go back to our browser, now we have all black. We can't tell where it's at. So let's go into our style and let's pick a different color here. Let's make something more Space Invader colorish and just get a nice alien green going. Okay. And save that. And then that way, okay, now we can see, and voila. Without any thought or trouble or effort, we have centered a div, the elusive centering of an HTML element. Okay, and so we're all set. Now we have a nice canvas. We didn't have to think about CSS or anything. We've got a separate style sheet. Now we can go ahead and keep the changes because that is what we want it to be. Okay, we'll go ahead and keep that. And so now it's asking us, do we want to keep this one as well? Yes. All right. And you notice even though it had that extra style tag that it forgot to remove, the edits we made were preserved when we clicked keep. Okay, so now we have a basic structure set up, and this is a key point in how you keep from getting ahead of yourself when you're vibe coding, when you're letting AI do all this heavy lifting. So we still want to preserve atomic commits. We want to use Git the same way we would if we were hand coding this, and every little feature that we implement and get working, we want to start making commits so that if we get to a point where we are just completely broken, we can't figure out what's going on, and we need to go back, we have that Git history to roll back. So now we'll say, let's open another terminal, and let's just say I'm not that familiar with Git. I'm going to ask it, how do I set up a Git repo for this project? Can you, again, walk me through step by step so that I learn? And you won't have to keep telling it to walk you through step by step. It'll kind of pick up the context that you keep asking for step-by-step instructions, and you'll be able to just ask it for what you want to do next. But when you're first getting the conversation started, it's good to kind of prompt it a little bit and give it that context of how you want to interact, how you want the conversation to go. So, all right, we're new developers, we want to learn. Okay, so it's going to give us the command right here that we can run in the terminal and explain what it's doing. And this is how you can use it to learn incredibly fast, because going out and reading the documentation or reading through a tutorial on how to use Git, it can be very cumbersome. There's a lot of information out there. There's good information, bad information. And then it's also adding, okay, maybe we didn't know about a git ignore file, which we're definitely going to want to have since we've already installed node modules especially. So let's go ahead and do that. So now we can apply in the editor. So we can have it create the file. Let's open our file tree here. So we can just have it. What I want to do is actually do the git ignore first. Okay. So let's go ahead and do that. No, I don't want to do it there. Let's just do it ourselves. So let's create a new file, .git ignore. Okay. And now we've got our cursor here. We're just going to use this, insert it at the cursor and save. Okay, now we can put this in our terminal and initialize our Git repository. Okay, now this is just initializing a local Git repository, but this gives us our changes and gives us our tracking. So now we want to get our initial commit in so that as we continue to add features, little by little, we'll have those diffs as we're saving our work and moving on to the next feature. And this is one of those steps or approaches that will keep you from getting into that vibe-coded dumpster fire as you build your project. You can actually kind of move in a logical fashion, still being creative and not worrying about how to write the code, but having something that you can use. And of course, it's also giving us command line. So git add dot is just adding all the files. Now we can also use the visual interface in VS Code and just, we can say this is our initial project setup. And we can just add all files because we haven't done that much yet. Not the most atomic commit. We could certainly break that into smaller chunks, but now we have all these staged. And so git add dot is just doing that. It's adding all files to the staging area. You can see staged changes here. Okay. And then git commit dash m is just saying that we're going to give it a message, initial commit. We put our message up here in the graphic interface, and then we can just click commit, which will do the same thing as this command right here. Now, if we want to set it up on GitHub, we can create a repository and add the remote origin that we want it to push to here. I'm not going to do that in this particular project. I've already got one up on DevPath, the initial example that I built to kind of work out what I wanted to do in this, and here's the next commands. So this is great. It's actually showing you everything you need to do to get fully set up, and all we did is ask it questions because we don't know what we're doing yet per se. You know, we want to set up Git. We know that's a thing that we're supposed to be doing, but we don't know how to do it yet. So by phrasing it as a question, it's giving us step by step, which is going to teach us the fundamentals of how to do things properly. Okay, so we'll go ahead and commit this. I'm not going to publish a branch because I haven't set up a remote repository. We're just going to go back to our file tree, shrink this down, and close up that git ignore. We don't need that anymore. We really don't need this index HTML open anymore, or our package JSON. Really probably don't need that either, or a config. We're going to start working in our main.js and start working on some of our game logic. So we've got if we notice, we've got our dev server running with Vite, which gives us this functional canvas here. We've nothing going on with it yet, but now we can start building out our game. So what do we want to do next? Well, why don't we get our player ship on here? Okay, so now let's move on and prompt it for, we've got our specs. What do we want to do? We want a player controlled ship that can move left and right and shoot bullets upward to kill the space aliens that float down. Now, it's tempting to just let it do all this in one shot, but what I want to do so that we can build this in a logical fashion is let's just draw the ship on the canvas first. So let's create the player ship. It can be simple pixel art, a rectangle with a rectangle cannon pointing upwards. Now, we'll say, okay, I've never used phaser. How can I go about this? Do I need to go create a graphic? Can we draw it on the canvas? So now I've given the task, but I'm going to finish it off with a question. So how can we make this using phaser? And I want to explore the options that I have. So we can add a graphics object. So this is teaching me about the phaser API without me ever going and looking at the phaser docs. Okay. We can use fill rect to create it and then position the ship and move it around. Okay. So now I'll update main.js to include this. So it's generating edits to the main.js file. And since we've set up our Git, we're going to see the diffs here, although actually Copilot might show you the diffs too, I think, even without Git. So now we can take a look at these highlighted areas and actually try and understand what code it is writing. So simple pixel art, it's going to make a white ship that's 20 by 40, and then a cannon that's 10 by 15. Okay. And we can see this .player ship. So it's created a graphics object in the create function. Okay. And it's using canvas to draw. What is it doing with the cursor keys? Add keyboard input for movement. Now see, it's getting ahead of itself. I didn't ask it to do the input for movement yet. So it's using left and right. Okay, so this is already saved. We don't have to save. It's not permanently added to our project yet, and we don't want to just click keep. We want to go look and see. Okay, and we hit if we get into this window, look, perfect. So now we have an issue. So it almost got it right, but you notice it's actually drawing, but it's not updating in the game loop. So it's moving left and right with the arrows, but it just ends up drawing a line, and that's not really what we want. Okay, so, don't want that open. So what we can do is we can ask it questions about the code, what it's doing. So it has some functionality in the update, but what it's not doing is clearing the previous movement. So we'll say, okay, we don't know how to fix this. What do we do now? So again, we're going to ask it questions. And this is the real magic in how you work with these AIs, is continue asking questions. Make sure you phrase things as questions. I can't emphasize enough. Talk to it like it's a senior developer that you're going to for help when you don't know what to do to fix the issue you are having with your code, and ask it to explain what it's doing. So I'm just going to tell it there is an issue with this ship. It moves left and right, but looks like it's drawing across the screen, not moving. Okay, so we'll say, we're just going to describe the issue. How can we fix this? Okay, and we're going to let it figure out, and let's see what kind of solution it comes. Okay, so this issue occurs because the graphics object, and so we're going to go look and see, okay, what is the graphics object? Okay, it's this constant that it created up here. And then it used this graphics object. It used fill rect. Oh, and it's generating updates to fix it now as well. Okay, so it used this to draw the ship. Okay, and if we didn't understand any of this code, we can ask it questions about specific lines and ask it to explain what's going on this line of code. Okay, so now we've got some new updates, and let's see what it changed. Is it clearing it? So it should be clearing that graphics object somewhere. Okay. So now we can see it added this .graphics.clear. Okay. And it's explaining that to us. Create the graphics object once in the create method, and the update method, reuse it in the update method. Okay. So it's explaining what the problem was, which is going to help us learn what went wrong and how to fix it. Okay, now, so this, having it explain it is absolutely so powerful in learning to code. It's great, love it. Okay, so let's go back and check out, let's see if we've got it working. And look at that, voila, we have our ship moving side to side. Does it stop? Stops at the edges. So it even figured out the edge collision to stop our ship movement correctly. All right, so we've got a ship that moves side to side. It's drawn on the canvas. I think it's a little far off the bottom. So let's ask it, can you move the ship closer? Actually, instead of asking it to do it, let's ask it to explain how we would do it so that it will point us to the place in the code where we can go manipulate it, and that's going to help us get a better understanding of how the code is working. So how can I move the ship a bit closer to the bottom of the game canvas? Okay, and let it explain to us what we should go do. And it's editing it again. Okay, the ship has been moved to the bottom of the canvas by adjusting its vertical position, ship Y, in the create method. Okay, so that was a little weak on the details. Maybe we need to emphasize, please give me step-by-step instructions if we need more detail. This is fairly simple, so we can go look at the create method. So let's find here's our create method, okay? And then we're gonna look for ship Y. So ship width, ship height, ship Y. Here it is, this.cameras.main.height. Minus 30. Okay, so let's see where that placed it. Okay, okay, much better. We're much closer. So now we know if we want to adjust that further, we can come in here and say, you know what, I want it all the way at the bottom. Let's try 40 and save and come back out to our canvas here. Let's go even further. Let's go 60. Oh, see, I'm going the wrong direction. Okay, so now we're actually getting further. So now by playing around with it myself, now I'm starting to understand better. Oh, minus 60. So actually, if I want to go closer, let's change that to 10. Okay, and save and come back out to our browser here and boom, now we're way down on the bottom. Okay, that was too far. So maybe we make this 20 and save and come back out. And now we're right down on the bottom of the canvas. Perfect, no gap. All right, and we have a little better understanding of the code that's been written. And of course, we could take the time to read through here and understand further and ask questions about particular lines. Like, we might want to know, how does the keyboard movement work? Well, we can see it's also adding comments for us. Add keyboard input for movement. Okay, great. And then in the update, speed, so we can adjust how fast the ship moves. All right. Prevent the ship from going off screen. Oh, okay, so this is where we stop it at the edges of the game canvas. All right, so I'd say that's a pretty good amount. We certainly don't want to do any more than that in one step. So what I'm going to do is go ahead and, okay, we're going to come out, double checking our canvas. We've got no errors in the console. It's still behaving. It's still stopping at the edges of the canvas. Okay, that's good. So we've made a small incremental change. We're going to go ahead and keep this and done. Okay, so now here's the next step in the process to make sure we stay on track and keep our project manageable. As we add more features, we're going to come out here and use Git just like we would if we were writing the project ourselves. And we're going to look at this commit and give ourselves some notes. What did we do here? Well, we drew the ship on the canvas and added the left-right movement for the cursor keys. Okay, and now this is going to give us the Git history. So if we look back at this project later, if we have somebody else come collaborate on the project later, instead of hundreds or thousands of lines of code for some feature that you vibe coded and didn't do this for, now we have a traceable history that we can look back at and figure out what's going on if we have an issue when we add more features later on. So we're going to write a meaningful commit message here and say added player ship to canvas with arrow key movement left and right and edge of canvas. I don't know if we should call it, it's not necessarily collision, but limit edge of canvas stops. So we can get into what the difference is in collision later, but at this point, yeah, we haven't even brought in the physics engine. So I don't think I want to say collision there because we're not reacting with a collision at this point. We're just making sure that the ship stops at the edge of the canvas. All right, so we can add that to our commit. And now we have our tracking. So we have our initial, so, in our Git history here, we have our initial project set up. We have our adding of the player ship, okay, in our working tree. So now we can close that up and go back to our conversation with Copilot. Now, what do we want to do next? Well, let's see. Let's go back to our ship here. So left, right movement. So we could either move on to making the ship shoot, or we could create our enemy ships. Why don't we go ahead and complete the shooting functionality? All right, so let's move on to the ship's shooting functionality. And again, walk me through step by step how to implement the feature. So because it kind of jumped the gun on the left-right arrow movement, I'm going ahead and reiterating, I want step-by-step instructions. I want it to explain to me what it is we're trying to do, because I want to learn about the phaser library, or I want to learn about, whatever task it is you're trying to accomplish in your project. Okay, so now it's perfect. It's given me much better instructions to implement shooting. We'll use a phaser group. Okay, so this is a new object that we haven't seen in phaser yet. So without going and digging through the phaser docs and looking what could I use and debating, it's giving me the answers right here. It's pointing me in the right direction so much faster. Okay, so we're going to create a group. What is a group? This allows us to handle multiple bullets efficiently. Great, sounds like a good solution so far. Now, create a bullet. Each bullet will be a simple rectangle or pixel art that moves upwards when fired. So we're going to use phaser game objects graphics class to draw the bullets and attach it to the spacebar key to fire the bullets. In the update method, we'll move the bullets upward and remove them when they go off screen. Right? We don't want to just fill up our memory continuously creating more bullets, so that sounds like a good plan. Now I'll update main.js to create this. Okay, so now we can kind of scoot back over and take a look at what it did. So these highlights, we can see in the green here, this is the first thing. So in the, what are we inside here? We're inside the create function, okay? So this is the built-in function that we get from phaser, right? And it's going to create our bullets. So what I get highlighted here. So this.add.group, okay? So this is a built-in from phaser, and then add the keyboard, okay? So this is .input.keyboard, so we know there's built-in methods we can use to listen to keyboard events. And there's even handy dandy constants for selecting particular keys. Awesome. Didn't know that about phaser. Now I do. Now I can use that in future projects, and I'm learning all along the way. It's showing me how to implement this. Okay, so now let's look at what else did it do. Let's get over here in the, now we're in the update function, okay? So we can see that it's broken us into that. Oh, that's really nice that VS Code does that now. So as we scroll down the page to this block of code, it's showing us what code block we're in, even though the top of the code block is actually way up here. So as we scroll, it's got a little sticky header here. I like that. That's very convenient. Okay, so let's look at what it's doing. Handle shooting. It's handling the key being pressed down. It's updating the bullets. When they go off screen, it's removing the bullets. Okay, it wrote a shoot bullet function that creates this rectangle. So let's go see if that's working now. Okay, so we've still got our left-right movement. Oh, and look at that. We have bullets. Very cool. And what did that take us? It's just moments. Spent more time explaining it than it really took. But we're continuing to gain understanding as we go of how to use the library, how to use, just how to build things. Maybe you're still learning JavaScript. This is teaching you about JavaScript. And if you don't understand something, you just ask it a question. Ask it to explain the shoot bullet function. Okay, so perfect, looking good. Let's keep this rolling. This could be a really long video at this point, but I hope you're getting a feel for the process that you can use to build things that are maybe out of reach in your current development skill level, but also learn how to do it while you're at it, while you're doing it. And that is the real power of this vibe coding approach. And you can see, I think at this point, how quickly, if you really do know what you're after and you're just trying to rapidly prototype something, how fast you can iterate through. So I'm going to go ahead and keep these changes because we don't have any errors. And again, back to Git, we're going to add a meaningful commit message. So add player ship bullet group and shooting function. Okay, so if we ever have to go back, we've got tracking of it. We're going to commit that, and we're adding all these little notes to ourself, our future self, that we will appreciate later if we ever want to take this to a point where we do something meaningful with the project. It's not just a prototype. That's the real difference in where these projects fall off the map. So moving right along, we've got a player controlled ship. It moves left and right. It's shooting. Let's create some enemy ships. All right, so enemy ships move left and right and descending. So let's now create the enemy ships that move left and right and descend each time they collide. So I want it to use collision. So I'm intentionally using the word collide. We'll see how it interprets it. But let's now create the enemy ships that move left and right and descend each time they collide with the edge of the game canvas. All right. Now, you notice I didn't tell it to give me step-by-step instructions anymore, but now that further up in the conversation, since we told it that, now it's beginning to do that automatically with each step of the way. So it gets easier to write your prompts the more context your conversation has. All right, so now to create the enemy ships, what are we going to do? We're going to create a group again. Okay, sounds reasonable. We want more than one enemy ship. We'll create a grid of ships at the top of the screen. Sounds good. In the update method, we'll move the enemy ships left or right. When they collide with the edge of the canvas, they will descend and reverse in direction. Very good. Sounds like a plan. Handle edge collision. We'll check if any enemy ships collides with the edge of the canvas and trigger the descending movement. All right. So let's see what it did this time. We've got some changes up here in the create function where it's creating an enemies group. Okay. It's given it some rows and columns. It's given them sizes, spacing. It's got a couple loops for adding them to the group. All right. And it's setting an initial direction. Does it do that somewhere else? No, that's it. Okay, so we got this block, and this block down here is in our update. All right, so what's it doing in our update? Let's close this down so we can see a little more. All right, I suppose I should do that up here so you can see the entire code. All right, so this is what it has added. Adding some rectangles again. What I don't see, so I don't see it adding the physics engine yet for Phaser. So we'll see how this works. It's probably just moving, and I can tell you from experience, when we go to add the physics for the collision detection of bullets and player to enemy ships, some of this may be problematic, but let's keep rolling. Should it descend? Okay, so we're in our update this is where it changes direction and descends. Okay, great. So let's go out and check out what do we got going here. Aha. We have enemies and we can shoot at them. Of course, we haven't set up collision yet, but they are moving and descending as up. But I see an issue. Can you spot it? All right, so on the right side, if you notice, it's not going all the way to the edge. And on the left side, it is actually going a little past. Okay. So we could decide, I'm okay with that. You know, maybe we want to make it so if you shot enough enemies, maybe they can go off the screen and respawn and come down. Depends on what you want to do. So we could come back into our conversation here and explain to it. Pretty good, but it stops short on the right side and goes past on the left. How can we adjust the edge collision points? Okay. And we're going to let it figure out, what's going on and point us. Hopefully it's going to explain here. If not, we can ask it another question. Okay, so they have been adjusted to account for half the ship's width. Okay, so it's plus 100 here. What else did it? So it changed that. What else did it change? Oh, it added this whole block down here in the update. Okay. So we'll just go with, I'm a little confused. What did it? So can you please explain the changes that were made? Okay, because we don't want to just accept mystery. We want to know what it's doing, right? We're trying to learn. Okay, so the updated code. If the adjusted edge collision points, updated code. If the enemy divided by 2 enemy width. Okay, so it's this adjust edge collision. Okay, great. So now we kind of can see what it is. Previously, this was stopped short. So now let's go out and see if that change actually worked, because I have a feeling it's not entirely correct. Okay, so I'm going to reload to get the alien started. Okay, we're hitting the edge on that side now. Oh, it did get it. Yep. And yes. Okay, great. So, perfect. We have an explanation of what it had to do to fix it, which gives us ideas for when we're writing our own code, what we might have to do to fix other issues. It's kind of long. It's hard to fit everything in the screen zoomed in like this, but there we have it. All right, so it's functioning as intended. Let's make sure everything is still working. We can still move our player. We can still shoot our bullets. And the aliens are moving towards us. So moving right along, this certainly would have taken far longer to go out and read documentation and figure out how to build manually, even if you're experienced. So we're going to keep these changes and we're going to go back to Git and again give ourselves a meaningful commit message. Now, of course, the beauty of tracking it in Git is as we're going, it gives us another opportunity to read through and review the code that's being changed, look for anything that is maybe a little off, or, oh, wait, we missed fixing this or that. Gives us another chance to reason about the code and try and understand what it's doing, so that as we go, we're building something that we understand. It's not just a complete mystery, even though we're letting the AI do all the heavy lifting for us. All right, so what we did is we added the alien enemy group with descending movement on edge collision. Okay, and we're going to commit that in and keep on rolling. All right, so let's close this back up so we can see we don't need our working tree anymore. And let's figure out what feature do we want to handle next. All right, so we have our enemy ships moving. All right, good stuff. We're on to collision detection. All right, so let's do player bullets versus enemy ships to start. All right, so let's work on the collision detection of player bullets to the enemy ships. The enemy ships should be removed when hit with a bullet, and the bullet should also be removed. Because we don't want it to shoot through all three. I mean, maybe we do, maybe we don't. I think it'd be a little more fun if they're so. Now, we're going to let it do this heavy lifting. All right, and again, since it's got our context, it's doing a little better job of explaining as it goes. To implement collision detection between player bullets and enemy ships, check for collisions in the update method, right? So the update method in Phaser is our game loop. So we talked about in the very beginning, games have this continuous loop that runs, and that lies in the update, built-in update function that we get from Phaser. So kind of like a life cycle method, if you've ever done any React, especially old school React, or web components also have a life cycle method that automatically gets fired by the browser and does things on certain events. Now, the update method automatically gets fired by the Phaser library framework and creates the game loop for us. So let's look at what it's done here. Okay, check for collisions between them and remove them if they collide. So I still don't see it using the physics engine, which is kind of interesting. Maybe this is going to be our first error. What? Let's go see what it's doing. I don't think that's going to be enough to make that function. Okay, so right now we reload to, oh, interesting. So very clever. It's actually making it work. without even diving into the physics engine that I see, our ship still goes back and forth all the way. We can shoot. Very nice. All right, so we are moving right along. We have bullets that fire and remove enemy ships. Remove the bullet and the enemy ship. All right, so let's look at what it did, what its approach was, because I had a little different approach in mind, but I'm kind of interested in what it did here. Check for collisions. So for each bullet, gets the children of each enemy, and it's checking the positioning. Enemy X plus enemy width, and then the bullet. Interesting. Well, that's kind of clever, actually. So and it's explaining. So yeah, now this is a good learning moment. Let's look at what it did versus what we could also, what I was expecting it to use was Phaser's built-in overlap method. So, what it realized is, but since we're using custom shapes, rectangles, we'll manually check for overlap using bounding box logic. Okay, so I was expecting it to use the overlap method, which would have thrown an error with trying to use the drawn shapes like that. We'd have to actually set up a sprite sheet or create some images and attach them to a physics object, which would have gotten us implementing the Phaser's physics engine. So it was smart enough to figure out that because of how we had done the other pieces, that would be a problem. So it'll be interesting here. I imagine it's going to take a similar approach when we do collision for the aliens and our player ship. What's interesting is when I did this the other day, I actually ran into the error, just kind of prepping for this video, and had to create a couple images because it did use the physics engine. So clever, all learning. And of course, if we wanted to, we could tell it, oh no, I want to use Phaser's physics engine. Let's refactor and go with that. But very cool. So we found more ways than one to solve a problem, as is always the case in code. So that gets us, let's see, we were implementing our bullet logic to remove ships, and we have that working. So let's just double check one last time. Now, one thing, we always have to hit reload to get the game started, although that's not a terrible thing. Okay, so we still can shoot our aliens. What happens if we shoot them all? That's it, we're done. So next features we could work on would be spawning more aliens, or maybe a start button so we don't have to hit refresh to spawn aliens. For now, let's go ahead and, I don't need that. Let's go ahead and keep these changes. They are working good enough for now, and let's go make another commit message. So add collision of bullets and enemies, and remove items which remove items which collided. All right, add that to our Git history here. And we can shut this down so we have some space again. We can look at our specs, but I think after looking at that last test, so I think there's two things we still need to do. We still need to spawn more enemies. One, if they reach the bottom of the screen, then we should start another batch coming down from the top. And two, if we've shot them all, we should spawn some more as well. And then we could get into a game over and maybe a start condition. But this video is already getting quite long, so we might scale this down a little bit. Let's at least get it spawning more enemies, so let's do that for now. And then we'll set up the collision between the enemies and the player ship. So let's now enhance our enemy group functionality so that when the enemies reach the bottom of the screen, or all enemies have been destroyed, we start another group coming down from the top. All right, let's see what it comes up with this time. All right, it's going straight to editing main.js. Let's see if it explains what it's doing or if we're going to have to prompt it some more. Okay, so it just straight added code. It didn't give us any explanation. Let's see how much we've got going here. Check if all enemies are destroyed in our update function. And check if the enemies reached the bottom of the screen. Game over true. Well, let's see if we get a game over. What's it gonna do? Okay, so it just spawned a new group because they made the end of the screen. Oh, let's shoot them all. Let's see if it... Okay, and we get a new group if we've shot them all. So that is essentially what we asked it for. I don't know if I like that it's named game over, because that's not necessarily game over. Game over will be when we collide with our player ship. But I suppose we can live with that for now to keep things going. And then it created a new function, spawn new enemies. So of course, again, we could ask it to explain the changes it's making here in the interest of continuing forward and getting into the player collision. I'm going to say, let's keep this and move on. What else did it add? 1, 2. Okay, so it removed all this spawning of the enemies here in the create function and replaced it with just a call to the new spawn enemies function. That's fine, that's decent. So let's keep that. Let's go to our Git history and add respawn of enemies. Okay, and we can commit that. And now let's get it to, let's add collision detection for player to enemy ships and trigger a game over when that happens. Let's see how it approaches this. I have a feeling it's going to skip the physics engine again, but that's okay. We're running long on time. But I think in general, you get the idea of how you can productively move through this, get explanations and understand the code, but still treat it in a fashion where you're publishing the code in a responsible way so that it's in a manageable way, so that if you want to keep progressing, you can come back day after day and iterate. You can come back months later and iterate and add new features. And also, you know, we've spent a lot of time explaining things and explaining how to prompt the AI and how to be careful about keeping changes. We didn't get into a lot of error debugging because it avoided my little traps today, but you know, we'll get into that in another episode. I think let me know in the comments if you guys like this style of tutorial. I can definitely see where this could be useful for a lot of different teachings. That's a good way to say it. And we can certainly, it's nice to see something substantial accomplished in a reasonable amount of time when you're still in the learning process. Because, you know, when you're learning, to build something like this could take days, and we're accomplishing this in a very short period of time without stressing ourselves on documentation and still learning how to use the library and different methods of coding and getting different ideas of how we can solve problems in different ways. So interesting stuff. All right, so check for collision between the player ship and the enemies. Trigger game over. And we're adding some game over text. Okay, perfect. So let's go see if this is working. Oh, we've already got a game over. So looks like collision is working. Let's refresh here. And that is really slow. So let's go up here and see if we can speed up our enemy's movement. We have a velocity, player ship. I suppose I could ask it, how can we speed up the enemies? All right, this to enemies, add group. Oh, we've got it down in a spawn enemies. So let's go look at that function. Maybe we can adjust the speed there. direction, width. I don't see where it's using the built-in velocity from phaser, which would be nice. Let's ask it, how can we speed up the enemies? Increase the movement speed. Okay, we're in update. Specifically adjust the value enemy.x plus equals this dot enemy direction is what we're looking for. Enemy height. Enemy direction, reverse the direction. Okay, where else is enemy direction? Aha, times 2. Move left to right. Okay, so let's make this 5. Save. There we go. All right, so we got some faster movement. We can try and evade them. Oh, look, we're like synced up with them. They move just as fast as us. All right, come and get me. Oh, very nice. So that's awesome. If they make it to the bottom, they respawn. All right, let's just make sure they get down here and collide with us. We can try and dodge them, but they're going to make it down here. And can we sneak in between them? Oh, they got us. Game over. All right, perfect. So that is as desired. Quit opening that. Okay, so we've got a game over that triggers. Looks good. To start a new game, you could just refresh the page. All right. If we shoot them all, what happens? Do we still get more aliens or do we get a game over? Because that naming was a little funky. Aha, we still get more aliens. Okay, perfect. So I'm going to call that good. We're going to keep those changes. We're going to go into our Git log and say add player to enemy collision and trigger game over. All right, let's log that in, commit that, and let's see what we've got left in our README. We didn't implement score tracking. Maybe I'll leave that as a challenge for you to see if you can take this further. I think since this came out a little bit differently than the first example I built, I'll go ahead and publish this repository on GitHub as well, and you can look at the 2 different versions. I'll put the link in the description to both. They'll be in the dev path GitHub. And I think this is a good place to kind of wrap up. Like I say, this video is getting quite long. The camera already went dead on me once. I had to restart. So I think we've had some key lessons. To wrap up, I would say, just to reiterate key points, vibe coding it's definitely got its place. It's a new paradigm to build projects, and I think we can build very fast but we need to be careful about still having some sense of best practices and, following the same traditions we have of small atomic commits, work on one little feature at a time, and in all honesty, you get a better result at the end of the day. You get something far more functional than when you try and shortcut and just ask it to generate me Space Invaders. It wouldn't come out this good. We're not quite at that point. And even if the AI was capable of building a fully functional Space Invaders game, which some of them may be at this point, that doesn't really build anything unique. There'll be a million copies of those. The point is to still be able to build a new project, a new product, whatever your new idea is, in a way that's going to match the creativity that you've come up with and what you're trying to accomplish. And the way to do that is in a structured way, not nearly as structured as traditional coding has been. This allows us a lot more creativity and takes a lot of cognitive load off of us as developers so that we can progress faster, have less stress, have more time to spend with our families, and yet still get more work done. So there's definitely room for this to be extremely productive for experienced developers. There's room for this to be an amazing learning tool for new developers when treated carefully and with a little bit of guidelines and structure to keep you on track. And, that could be said of regular development too. You've got to stay organized and keep track of your changes and iterate in a reasonable, logical fashion. So key points in terms of how you prompt AI. Ask it questions. Talk to it like it's a coworker. Speak to it just the way you would another developer, and you're trying to solve a problem, you're stuck on something, share error messages with it. So when you do get error messages, say, hey, describe the behavior that you're seeing and give it the error messages that you're receiving in the console and ask it how you can fix it. Rather than just saying, I got this error, fix it. You get better results. It's just, honestly, even with managing people, you'll find when you approach things as a question, you'll get far better results than when you bark orders at people. And interestingly enough, the same is true with these large language models, because guess what? They're trained on things that people wrote. They only know things that people have written. And it reflects in how they come back to you with solutions. So when you treat them the same way you would treat an employee, positive or negative, you tend to get similar results. So give it specific details, just like you would if you were the senior developer asking a junior developer for help. If you give them a vague task, you're going to get a vague piece of work back. If you give them specifics and give them context to work from, they're going to help. Be humble and ask questions. Hey, I don't know how to do this. Tell me how to do this thing. It will come back and help you figure that out. And the nice thing is that it can search through mountains of documentation in fractions of seconds, whereas that takes us hours. So it can really save us a ton of time. And, if you're working on the cutting edge of things, you may have to link out to the most recent documentation or something like that. But you can still lean on these AIs to help you get through it faster. You just got to realize you're still the developer. Okay, you still need to lead the task, and you've got to keep things organized and move in an incremental, iterative process, and you will get good results at the end that you can move forward and do productive things with. With that, I think that is the majority of my tips and suggestions on how we can increase productivity and learn with AI. And we came out of this in a reasonable short period of time with a functioning, simple but functioning version of Space Invaders game. Get my cursor out of the way. And you can absolutely, take this on, add more features, add a scoreboard and keep track, make the aliens shoot back and set up collision from that, prompt it to refactor and use the phaser physics engine this time, or look at the other project I did and see what you like about each approach and see if you can't prompt your way through building it the way you like best, or add new features that maybe Space Invaders never had. Put your own twist on it. So with that, game over, Space Invaders. That's the end of this video. I hope you've enjoyed. I hope you've learned something. I hope this will help you learn even more, even faster, and be more productive in your journey to be a developer, to get your work done faster if you're already a developer. Thanks for watching. Lots more content coming. We've got a ton of new stuff coming for 2025. If you like this video, please hit the like button. Let us know in the comments if you'd like to see more of this format of learning. Obviously, I think we could speed it up a little bit, but let me know what subjects you would like to learn about, and we will add them to the queue. So once again, thanks for watching. See you in the next one.